Hi guys, welcome back to my YouTube channel. In this video, we are going to talk about Google Zanzibar. This is still in authorization series video. Before, we have talked about authorizations models. We talk about policy as a code authorization systems. And actually there is another type of authorization systems called graph based authorization systems. So Google Zanzibar use that model. So we are going to take a look. So without further ado, let's get started. What is Google Zanzibar? They publish a paper, Zanzibar, Google's a consistent global authorization systems. So this is Google authorization systems for these products. And they have a requirement to build one authorization systems that's flexible enough to be built on top of different policies, because they want to have the same user experience of authorizations while using different products. And it needs to be scalable for billions of users and trillions of objects. It needs to be highly availability. The performance needs to be very good, which can handle millions of RPS under very short amount of time worldwide. Wow, impressive. So we are going to take a look about model, language, and API in this video. And if you have read the paper, it's actually the second sections of the paper. So let's begin with relation tuples. This is how Google models the relations between object to users and object to object relations. So this is the notion of it. So tuple is combinations of object hashtag relations at user, right? What is an object? Object is combinations of namespace and object ID. What is namespace? We are going to see that later. User is user ID, or it can be user set. User set is object hashtag relations. So let's see. Users is a person's or service account, and then the ID of user ID, it's unique integer ID assigned by a system called Gaia. And namespace, it specifies the type of objects, like for example documents, folders, organizations, right? And then also their possible relationships. Object represent a non-user entity, right? A unique identifier prefixed with namespace. So we write down objects with this format: namespace, right? Namespace is a document, and what is the document ID? 1, 2, 3. Relations, how one object can be related to another object, right? I can be an editor of a document, I can be an owner of a document, so on and so forth, right? So in the next slides, we are going to see an example using Google Drive as the example, right? So let's see. I have 4 quadrants here: namespace, previewer, tuples, and query. So let's see the basic example. Namespace, right? I have a document namespace with name doc. It has 3 relations: owner, editor, and viewer. We can make a preview of that like this. Google Drive, documents. Document is the namespace. It has 3 relations. So we can write down the tuples like this. Doc, roadmap, owner, 9. So if you remember the notions before, we can read it like this. User ID 9 has owner relations to a document of roadmap, right? User ID 10 has relations of editor to document named roadmap. User ID 11 has a viewer relations to the slides document. So we can do the evaluations to check whether user ID 10 has a viewer access to roadmap document, and the response will be false. Why? Because in this example, user ID 10 only has an editor relations, right? So by the way, check is an API in Zanzibar that to evaluate the relations, right? So if we think of Google Drive, basically if a user has editor relations, that user will automatically has a viewer relationship, right? Yeah. So how to fix that? Well, we can write down more tuples for that user, but it's not efficient. So let's try to change the namespace configurations using a concentric relations tuples. In the concentric relations tuples, we still have 3 relations: owner, editor, and viewer. But now we have a new one here, user set rewrite. We are going to rewrite the user set of this relations editor. Let me bring my pointer. All right. We use a keyword union. Union means any one of these. Wait, okay? I will explain that to you later. Inside the union, there is a keyword underscore this, meaning every user that has editor relations. And the second one is computed user set with relations owner. With this keyword computed user sets relations owner, now every user that has relations owner will also have relations editor, right? So computed user set here is to do inheritance. Now what is union? Union means that to have editor relations, users can be assigned to editor relations or owner relations, right? The other options is intersections. Intersections means if we use intersections replacing the unions, it becomes like this. If a user wants to have editor access or relations, they need to have editor relations and owner relations. Exclusions means users should have one of these relations, editor or owner, but not both. All right. So we do the same with viewer relations. We say that everyone that has editor relations will be a viewer relations too. So if we draw the preview, now every relations has this arrow of concentric relation, right? If you are an owner, you are an editor and a viewer. If you are an editor, you are a viewer too. So if we use the same query like before, now the answer is true, because ID 10 is an editor. Now he is also a viewer. Group relation tuples. So in Google Drive, we can create groups, and then we can assign access to that group, right? So that every group, every member of that group will also have the same access. So the namespace configurations is the same, but now we add a new one called ORG, or organizations, with relations name member. So this is the preview. So right now we have organizations namespace with a member relations. So we can write the tuples like this. User ID 12 is a member of Contoso organizations. Contoso is the ID of the organizations. And every member of Contoso organizations will have viewer relations to document name readme, or with the document ID readme. So if we trying to check if user 12 has viewer access to readme document, the answer is true, right? Because user ID 12 is a member of Contoso organizations. Next is about parent-child relation tuples. What is parent-child relation tuples? In Google Drive, we can create a folder. Inside that folder, we can insert another folder or documents, right? And if we set some relations or access in that parent folder, automatically the same access will be inherited to the child, everything that inside the folder, right? So we can configure the namespace to accommodate that conditions, and this is the namespace, right? It's huge, but let's see the preview first. So now in Google Drive we have 3 namespace: folder, doc, and organizations. The new one, folder, also has owner, editor, and viewer relations, and they're also concentric, but with editions it has parent relations. Documents also has a parent relations. So we are going to use these parent relations to link a parent relationships between folder and document. So if you see in the configurations on the left, you can see the folder namespace. There's a parent relations, and the document namespace it also has a parent relations. There is a new conditions under the union, tuple to user set, and these conditions that enables us to create that parent-child relations. So basically we say that, hey, if you have relations parents with the parent folders, with the object of parent folders, with this relations editor, right? If you have editor access to the parent folder, you will also have editor access or relations to the documents namespace. Okay, that's how we read these namespace configurations. So we can write down these tuples as an example. README document is a child of planning folder, or the other way around. Folder planning is a parent of document README. And user ID 13 has a viewer access to planning folder. So we are going to check if user ID 13 has a viewer access to README documents. The answer is true, because readme documents is the child of planning folder. And another examples. Alright, it's a bit exciting. Example. So there is a parent and parent relations. Readme documents is a child of planning folder. User ID 14 is a member of organization's Contoso. And every member of organization's Contoso will have an editor access to engineering folder. And engineering folder is a parent of planning folder. Try to answer these questions. If user ID 14 can view readme documents, the answer is true. Why? Okay, let's try to answer why from different perspective. So what we try to do basically in the previous slides is basically we use DAG, right? Directed acyclic graph. And then if you are not familiar with that, I have a video explaining about that. So check API basically it maps the models using DAG, and then it tries to follow the directions to find if user ID 14 has relationship with readme documents somewhere down the graph, right? So you can see here, right? User ID 14, member of organization Contoso. There is a readme, it's a document. It has 3 relations. And then there is a folder planning. It's a parent of readme. Folder planning also has 3 relations. There is a folder engineering, which is a parent of planning, also has 3 relations. So let's now try to follow the path to find whether user 14 can read readme document, right? So user 14 is a member of Contoso organizations, right? From these tuples, right? As a member of Contoso organizations, user 14 will also have editor relations to engineering folder. That's correct, right? Because engineering folder is a parent of planning folder, right? It means whoever has editor relationship here will have an indirect relationship to this editor relations of planning folder. And because readme documents is a child of planning folders, whoever have editor relations will also have editor relations to readme documents, and whoever have editor relations will also have viewer relations, right? It's a concentric relationships, and viewer relations can read the readme document. So the answer is true. All right, now let's talk about new enemy problem. What's that? New enemy problem is when we fail to respect the ordering between ACL updates, or when we apply old ACLs to new content. What does it mean? So let's see an example of neglecting the order of ACL updates, right? At time 1, Alice removes the viewer access from Bob. Okay, Bob, bye-bye. At time 2, Charlie moves new documents to the folder. At times 3, Bob attempts to read the documents that just moved by Charlie, but because the ordering of ACL is neglected, Bob sees the documents. So Bob becomes the enemy here. Let's see another example of applying the old ACLs to new content. At time 1, Alice removed the viewer access from Bob. At time 2, Charlie adds new content to the documents. Because the stale ACL is used, Bob's still able to read the documents, right? That's why Bob becomes the enemy here. So what is the solution of these problems? So the solution is by preserving causal ordering of ACL events. How to do that? Right? So whenever there is an event to update the ACL of or update the document, the content, the object, right? We will put the timestamp. So these events will be inserted to Zanzibar, and Zanzibar behind the scenes use Google Spanner. Google Spanner has a feature called True Time, which is to ensure that every nodes of Zanzibar Spanner will have microsecond resolution timestamp. So like basically the clock is synchronized for each nodes of Spanner, right? And then it's gonna do some replications, and then Charlie moves the new documents, right? It will also has the timestamp, right, inserted. So when finally Bob tries to read the new documents, because now every events before happened already have the timestamp, when we do the evaluation check, we can evaluate all the events based on the order, because we now have the timestamp stored in the spanner using True Times features, right? And that's how to solve the ordering of ACL events. Now, how to solve the second problems using the old ACL to evaluate, right? The option 1 obviously is by reading the latest snapshots, right? But that's expensive because there might be a chance that the data is not there yet in the closest replica of Bob, right? Because it's a globally distributed database, right? It tries to sync the data, so the data might not be there yet. There will be a delay, so it causes latency. So option 2, use a bounded staleness snapshots, but it has cons. But let's go back to the cons later. By the way, this is the options that Google chose, right? What is bounded staleness? Bounded staleness is an ability for reading some data from a snapshot of time window that defined by user. So we can define the time window of the snapshots to choose a slightly outdated or stale data but fresh enough for doing evaluations. Right? It's considered to be faster because it reads from the nearest replica. So we use this TZ timestamp, right, to check to read to the spanners, and it might be not the latest one. It might be there is a newest updates that is not captured, right? So therefore the cons here that there could be a risk of evaluating check based on outdated ACL data. So how Google improve these solutions? They introduce Zuki, right? Zuki is a Zanzibar cookie, is an opaque cookie. Opaque cookie means the cookie is not visible like cookie in website, all right? So it's a token inside the systems, enforced inside the systems, that represents a specific point in time. What does it mean? It means that when Charlie moves the new document into the folders, the response of Zanzibars will include cookie, Zuki, of timestamp Y for that document for that variations. And then this cookie will be stored internally inside Google Drive in the atomic storage systems. So then when Bob tries to read the documents, it will fetch the latest cookie for that documents, which is in this case is the timestamp y_zuki. So now when we check the snapshot, we can use this time window to read the snapshots, right? Which is, it is safe because we know that there is no more causally related events between timestamp y and timestamp z. And even better, when update of the global replication is finished in these timestamps, we can just select the timestamps between these two. It's more efficient, it's more fast because we can avoid the what's that called, tail latency. So this is the final slides. So Google Zanzibar provides 5 APIs, include the check API that we have seen before. The other API is read API. So the client of Zanzibar can read the relation tuples, for example, to display it to the users or to prepare a subsequent write. And write is to modify the relations tuple to add or to remove the ACL. Watch is to give the modifications event, the transaction events to clients, because clients can manage their own indices of relation tuples, for example, to do caching or to do audit logs. Check is API to evaluate the permissions. This is what we have discussed. And last is expand API, which is will flatten the DAG into a tree and give that tree to the client so client can interpret the relationship for their needs. Yeah, so that's all about Google Zanzibar for the second sections of the paper. I hope you enjoy it so far. Until the next video, keep learning and stay healthy. Bye bye.